Hello ATS 113 students, this is Dr. Shragi and I'm presenting you the reading coach associated with the 5th edition of the textbook. This is coming from chapter 10. It is the 4th lecture leading up to the 3rd exam. And for this day you're going to be reading pages 299 to 315. This is a section about the life cycle and development of cyclones, a process we call cyclogenesis. No introductory meteorology textbook has a good explanation of cyclogenesis. You're going to be mainly relying on your notes from today, but we're going to kind of go through this reading real quick and kind of point you to some of the more important things that you can get from the readings, but realize you do need to rely on your notes for this rather difficult concept. It's going to be related to this idea of polar front theory, so make sure you understand on that paragraph right there on page 299. Okay, so this idea of the life cycle of a mid-latitude cyclone is very important. You want to understand this concept of cyclogenesis, the process of strengthening a cyclone by decreasing its pressure. This little diagrams that's shown on page 301, by the way, are very important to understand. I'm not sure exactly why they're on this page. It seems like we would only have that idea a little later in the life cycle of the cyclone, but perhaps you'll be able to understand them at this time. On pages 302 and 303, this idea of occlusion, or when the cyclone becomes an occluded cyclone, is very important. On the other hand, I wouldn't really care very much about this business of the movement of cyclones on page 303. Here's where things start to get tricky. We're definitely going to talk about vorticity, this term that you see on page 304, but we're not going to really talk about it so much using Rossby waves as the example. Remember, Rossby waves are an example of troughs and ridges. We're going to talk about it in class more generically with regard to troughs and ridges, so it won't necessarily be explicitly a Rossby wave, but this idea of vorticity is important. On the other hand, notice how the book separates it into absolute vorticity, relative vorticity, and earth vorticity. We're not going to be doing that. We're just talking about it in a more general sense. What we're going to be talking about in class is probably most related to what the book here is calling relative vorticity. In general, the book really gets pretty complex at this point. It starts talking about things like dynamic lows and thermal lows and things like that. This is beyond the scope of this course, but I do like the figure 10.7 at the bottom of page 306 as being a good illustration of the three-dimensional structure of cyclones and anticyclones. I also think that this business of how surface fronts relate to the upper level pattern can be important. I would just skim through this section though, because I think the way we explain it in class is more relevant to the kind of questions that are going to be asked on the test, whereas the book goes into really what's quite a lot of detail. That's why, for example, I really wouldn't worry about anything associated with pages 308 and 309. On 310, though, I do like this blue box about a closer look at divergence and convergence. I think that there are concepts on here that will be important both on this test and actually on the 5th test, but obviously we'll have to come back to it at that time. I also think that it's a good idea to go through this idea of an example of a mid-latitude cyclone. This is a good way to learn about this kind of thing. For some people it doesn't work as well as others, but I think that this section is pretty short. It'll be useful to you. I certainly would not worry about this stuff, by the way, on pages 312 and 313 about short waves in the upper atmosphere. This is really interesting if you're an ATS major, but overall this is not important for the ATS 113 class. And finally, as we continue through pages 314 and 315, this is just more about this particular case study or example that the textbook is using to illustrate the life cycle of a mid-latitude cyclone. It's actually pretty interesting. I'd recommend working your way through it. But remember, your notes are going to be much more important for this particular material than the textbook is. There's just some ways in which the textbook amplifies what we learned in class. Okay, if you have any questions, please feel free to get a hold of me. This has been Dr. John Shragi.